So for this challenge, I picked two examples here to allow me to understand the overall idea um, of converting a non-deterministic table to a deterministic table. So the first example is actually a non-deterministic table. I used the data frame from the pandas module to visualize the state table by providing a list type, a dictionary type of my table's information. And the second example here is this should be a DFA here. It should be a deterministic table here. Sorry. An FA to DFA, sorry. It's an FA to DFA table. So this visualization actually is a representation of the conversion result of this non-deterministic state table. For my program, I declare a class here. This class have a bunch of exposed interface methods that allows user to add the input symbols through the add info method, the final acceptable states through the add final states method. Add transition to the states by call this add transition method. The user needs to provide a dictionary type transition parameter that has three different key value pairs that indicate a from state, a to state, and a input symbol. It also has the add start state method that allows the user to add a start state for this transition, the entire transitions. It has two methods that allows user to get the original state table and the converted type of the table. This base class has several initialized properties, and one of the property, which is the type, has to be provided when the user instantiates this class. So indicate which type the user wants to start off. So for my code here, I named my class as FSA, which indicated as a finite state automata functionality. I implement the add input, add final states, add transition, add start state, get table, and get table converted. These exposed methods here. I want to talk more about this add transition method. So this method needs to take in a transition parameter, and this parameter is a dictionary type. I list an example of how this transition should look like. So it must have three different key value pairs: the from, the to, and the on. So whenever a user calls this method, after he instantiates this class here, this method will also gradually construct a F map that will be used in the later code to convert this original F map to a converted type F map that will essentially get converted or parsed into a state table. This get table is essentially calling one single internal method, which is a parse method that will parse the F map to a list and return a human readable data frame through the pandas module. This get table converted which is the core functionality of the entire class. Because this method is essentially, we'll call this convert method as a recursive function that convert the entire original state table to a deterministic type table. And this convert method in the end, they will call parse, that will parse the converted fmap into a state table that is visualized through the pandas data frame. So this start converts, this whole block here is the critical part of my program algorithm. So I will demonstrate through the example I listed here. So what this code is doing is that it reads from the original table and generate the table from row by row, and eventually it gets this table at the end. That after finish the recursive part, it gets this entire table here. So this new table will start off from this S0 as the start state. So S0, when the input is 0, it will go to either S0 or S2. So for this new table, I put a curly braces outside of these two states to indicate it is a combined state of S0 and S2. And then on input 1, S0 goes to S1. It is a single state, so I directly move that state to here. So for S0, on input 0, it is a combined state here. 1, it is a single state here. And then it loops through these two states here. So on S0, S2, put it here on the second row. For S0, in original table, it goes to S0, S2. And for S2 on 0, it goes to an empty state here. So combine a empty state with S0, S2, we have the S0, S2 as a combined state here. On input 1, S0 will go to S1 on input 1, and S2 will go to S4 on input 1. So on S0, S2 as the combined input state, the output state will be S1, S2 as a combined state on 0, 1. So on 1 as input symbol. So for the second row here, I generate the function, the algorithm will generate this transition through this recursive function here, the whole block. And then it recursively it will read through S1, generate these things here, and it will read S1, S2, and generate the things here. Okay, so let's have the test running the example, so we know that the whole algorithm is working. So instantiate this class by provide the machine type, call at final states at input and at start state, provide all the basic information, get this machine ready to call the add transition method here. So for this entire add transition procedures, I call this method 8 times to get my state table ready here. So after this class get instantiated, I call fmap to get the overview of my f mapping. Call this getTable method to get my visualization of the state table that has been provided into this instance of this FSA class. And then I call this get table converted. It will return a visualization of a converted state table of the original non-deterministic type. So this new table is a deterministic type. And when I try to retrieve this F map converted, I just use the dot notation, and it will return the new converted F mapping that being used. That this mapping is the mapping that has been used to generate this visualization of the new state table. So yeah, this is my walkthrough video of my program challenge solution.